Welcome, Dr. Craig Stephen Wright.
Well, thank you, Steve.
So one of the themes that we really want to explore here is something that's right at the heart of Bitcoin, which is the Bitcoin script language. It's been the subject of quite a bit of misunderstanding and speculation. And in fact, it's something that we in the Bitcoin SV team have had to spend quite a lot of time focusing on, because as part of the Genesis restoration, it was one of the trickier pieces to work through. Now, I want to talk a little bit about the history of Bitcoin script and how it came to be, because I think, correct me if I have the date wrong, but August 2017, August 2008, the Bitcoin white paper came out. And it described a transaction as a chain of digital signatures. It didn't actually mention the word script at all. And then a while later, the Bitcoin 0.1 code came out. And in fact, that strict definition of a chain of digital signatures seems to have been replaced with a chain of valid scripts. Now, almost all those scripts use digital signatures. And so this has actually led to quite a lot of speculation about what script's place in the original Bitcoin design was. In fact, it's been speculated that it was a last-minute addition. So can you tell us about how script made it into Bitcoin?
Well, as I've said before, it's not really script. It's, it's a scripting language, but it's a predicate. So first we have to consider that it's a predicate system. Now, for those who don't understand, a predicate is a logical construct that ends in one of three ways, two of which are valid: true, false, and syntactically incorrect. So, there are things you can have that are neither true or false, of course, like this sentence is a lie. Yep. Those sort of things. So, but we don't worry about those because they won't pass anywhere. Mm-hmm. Now, why did I have script in there, or a predicate? Because you don't have a single way of using money, or how people use negotiable instruments or promissory notes or anything like this. So you can't really dictate commerce. And if you have a commercial system that is highly structured, then people will break it and find a way around it. So throughout history, if you study monetary history, you find very quickly that people in commercial endeavors always find ways around the system. Now, in something that is prescribed, if you don't allow people to actually create something outside of the base sort of methodology, then they're not going to use it. They're going to create something else. So if we want people using Bitcoin, we have to allow them to think of different ways of using it. Hence, sort of adding things like some of the original simple script items, like 2 of 3 and all of this. So the primary use case was always cash, but I wanted to see what other things people would invent.
And so the way that script has actually been used in the, I guess, the mutations of Bitcoin up until BSV restored the full functionality of script in the Genesis upgrade was severely constrained and limited. Yes. They have this notion of a standard transaction, and in fact, the largest part of the definition of that is particular script templates that were allowed, pay to public key hash being a common one that we most of us use every day. So the argument is made, why not, if you're only going to allow certain types of scripts, why not just hard code them? It'd be a lot more efficient, computationally efficient. But I think this goes to what you're talking about. If you end up in developer wars again, don't you? Someone decides, actually, I don't want to do pay to public key hash exactly that way.
Then you have someone sitting over everything going, this is what you need to do. And that opens up avenues for corruption and other such things. The developers then who sit in charge can be bribed. I'll add something that suits you, but not this guy, all of these sort of things. So if you want true independence, you need people to be able to do what they want without interacting not having to go to the great and mighty masters and go, excuse me, sir, please, can you add this?
So the flip side of that argument then is why not allow new opcodes? I would argue that you don't need them because you can replicate the functionality of almost any. But we will start talking about the restrictions of script shortly. But
well, there are two parts to that. You don't have stability when you allow new opcodes. So people will sit there going, but it's backward compatible, but it never really is. And it requires changes, and you don't have a stable system anymore. So as you start opening it up and changing things, you have to have everyone migrate, and you can't have old versions and new versions and things like this. So you end up with this system that becomes fluid, and once again, someone will be able to be bribed or paid off to add an opcode, or someone else will change something else that will affect things differently. And you can't plan in code how things will affect each other over time. So anyone who's done any secure coding, especially in assembly or C or anything like this, where it's not type constrained and it's not, you don't have all the controls around something like .NET or whatever else, you've got to remember that new functions can affect old ones. So opcodes, you might sit there going, this is perfect, I know how it works. But anyone who's coded for a while starts to realize you don't actually know how something that's added will impact old things. It's actually impossible. This is part of some of the research people like Straka and whatever else did in the past. When you add something, you don't know how it's going to impact everything else. Although the script might be a predicate, the underlying system itself, of course, is fully looped, fully sort of enabled with everything that a normal full compiler has to run. And when you start adding one function, how does it impact everything else?
Yeah. So there are some functions that are actually fully describable or able to be replicated in script. And I'll use the example of op-reverse because Bitcoin Cash recently went through a hard fork, and it appears the entire point of that hard fork was to add this one opcode. But as I've demonstrated in my presentation just a short time ago, op-reverse is quite trivial to implement in script. So that leads me to something that really bugs me about the history of Bitcoin, and particularly Bitcoin Cash. When we first started re-enabling opcodes, of course, this was back in the Bitcoin Cash days, the string opcodes, op left, op right, and op substring, ended up being replaced with basically op split, which you can now use in combination with some other opcodes to replicate the functions of those. But it does bug me that we basically, in case anyone doesn't know the history, we didn't really have an option here because of the politics of the time. It was accept this sort of minimal and slightly different set of opcodes that could give us identical functionality or not do it at all. What's your opinion on whether we should bring those original ones back? Is it worth the headache?
It becomes difficult now. We're moving from sort of an alpha to a beta and then eventually commercial sort of phase. And there was a little bit of leeway in the alpha stages of Bitcoin for experimentation. But we're really getting past that. People are building applications now. And once you get into that, you start impacting third parties. If we want to have a stable environment that people are going to build on, we can't start playing with it too much.
I agree. And the script opcodes are about as fundamental as it gets. Just for the record, of course, the functionality of left, right, and substring are completely replicatable using existing opcodes. And in fact, with some of the tooling, that it is fairly trivial to do so. It's the fact that it keeps me up at night and bugs me is probably more to do with historical politics.
I think a lot of that was just to bug me, because I sort of argued quite strongly that I wanted the originals and Armory did everything he could to make sure that didn't happen.
Well, in fact, that conversation, it was Gavin Andreessen popped into that conversation. And I mean, I genuinely think Gavin's heart was in the right place, but the original idea for OpSplit came from him. And to be honest, at the time, I was sort of quite enamored of the idea of simplicity as a principle. But it wasn't until later when I started considering the sort of underlying efficiency of being able to pull a single byte out of a very long string, and how that actually looks when you use OpSplit is quite a lot more expensive.
Well, this is actually an interesting thing. We spoke about something earlier today, which was Wozniak was nearly fired from Apple back in the early days of Apple because people were looking at how many lines of code he produced. And he was constantly coming up with negative results because he was taking and refactoring other people's code to make them run faster because he didn't like what they were doing. And he thought it was horrible and not efficient, so he rewrote everyone's code throughout the organization. And management, of course, just looked at this and said, "You're not doing anything," and just thought he was a burden. Now, this is probably somewhere where Bitcoin might change some of the attitudes. When people start paying per line of code, and it's not you're paying your staff how many lines do they do, and we'll give them a bonus if they get extra lines, which is very easy to do, by the way. If you want to get your bonus, you just put a whole lot of trash code in there that does nothing and slows down the system, or just puts a loop in for the sake of putting a loop in, or sleeps for a line, or all sorts of stupid things that you can then fix later and get another bonus. Anyway, but the fact here is now, if we're going to be paying less money to have a smaller script, one that's more efficient, and it's actually charged, then the economics come a completely different way to the bloat software that we're producing now. Rather than having how big can I make my software, hello Microsoft, we can go back to this small, efficient, sort of well-crafted code.
Yep. And Forth is I think a great language for doing that because of the discipline that it imposes upon a coder, which ironically is my very next subject. So when you took the decision that a scripting language, or you might even call it a virtual machine, needed to be a part of Bitcoin, there are probably a lot of choices in front of you. We've seen some token platforms use JavaScript, for example, as a compute engine. So why Forth in particular?
Forth is very small and efficient. It's a language I've used quite a lot in my past. My uncle was heavily involved in the Air Force, so my grandfather was an engineer and mathematician and other things as well. And in both cases, going right back through the 80s, Forth was a fairly common language that I used. Some C, eventually C++, but when I first started it was only C. I'm just making myself sound old now. But Forth, it's very small, efficient. It's very easy to check. It's very easy to write good code that you can find the errors and validate the results very quickly. If you look at something like Java, it's very easy to make mistakes and bad code.
And I think that has something to do with the enforced discipline required to manage stack state.
Some of this actually comes down to if you screw up in Forth, it won't work. Whereas if you screw up in Java, it can work, but every now and again you get strange results. Now, when you're talking about monetary and financial systems, it's not something you want. You actually want something that fails before it gets to the compile stage.
Yes, ideally, yeah. I mean, and Java is designed to be a fail-fast language. And one of the features I particularly like about it is static typing, because it forces things to fail a long time before you even get to compile. But
But you can still have things that are valid in Java but give you strange results.
Yes. Well, I guess where it fails, I mean, null checks, for example, are a common thing that get omitted. Probably the most common exception in Java is the null pointer. Well, that's again. You seem to be leading me along my agenda here. My next question would be how do you think Forth as a virtual machine is different from other bytecode style interpreters? Because I tend to look at Forth or script rather, and to me it looks very much like Java bytecode or assembly.
At that stage, it's very similar. And it's incredibly efficient. There are a lot of early embedded machines were actually created in Forth. And when people talk about raw operating systems on industrial Internet of Things, quite often these are actually built using a Forth or Forth derivative. Many people don't even realize that they're using Forth when they're coding some of these devices. So we have many systems that are critical that have been built on Forth over the years. And so if we look at the F-18 fighter interceptors, that jet, the system there for many years was actually built using a Forth-based language. Many of the missile systems that the US uses are actually coded in Forth. And a number of the other sort of high integrity systems have been coded that way. Now, not that I'm necessarily saying that that's military use and whatever else is what we should be doing and for that reason, but there's a level of integrity. So no one wants their bombing system to go off and bomb the wrong building or something like this, or a plane to fall out of the sky. So when you're talking about real-time operating systems that have to work and have to be secure, that's the fundamental sort of aspect of what we want for a financial system. We don't want a DAO type scenario where people can easily hack money. I mean, that's still codable, of course, in any system. You can forget to put in the key. You can do all sorts of stupid things. But the distinction here is you can make it good.
Yeah. So I think there's maybe an analogy between a Bitcoin script and an embedded system, which is a very common way that Forth is used. So I mean, imagine your tiny little IoT device out in the cornfields picking up weather data. In those embedded systems, maybe they're using an ancient processor like a Z80 with a kilobyte or even a few hundred bytes of RAM. So they're resource-constrained systems. And Bitcoin itself is not resource-constrained in the sense of the totality of the system, but there is a cost to the use of it. So there's an incentive to keep your Bitcoin scripts tight.
Exactly. Yeah. And as I said, when you're doing large scale, like many systems will in the future, particularly when I'm saying industrial Internet of Things, it's a different environment to home environments and whatever else, which includes what you just said with agricultural measurement systems and sensors. These are going to be something that corporations are going to want to manage effectively and efficiently. They don't want sort of code that is bloated, because if you can save 5% on it, that's a significant amount of saving for large corporations. So being able to cut down the size of your script and find better ways of doing it will actually be something people want to do.
So script optimization is something I should definitely look into building into my SDL, and maybe something the scripts team and
exactly. And over time, it's going to be something where people will probably have careers in this. Like now, we have people who are sort of test engineers and whatever else, or engineers who come in after the first lot to check whether code's been done correctly and validate and whatever else. We'll probably have refactoring engineers who will come in there and see if they can write the same code, but for a little bit less money. Yep. And that's probably a future career option for people.
And I think there's probably a lot of static analysis tools that can be done as well, because I mean, one thing that is probably well known in Bitcoin because of the fact that script-sig almost always just has constants in it, is that at compile time for a script, if all of the inputs to any function are known, you can simply run the function and replace all the function code with the output of the function. So for example, if I have a piece of script that says 1, 2, add, the result is 3. I don't need those 3 opcodes. I can just push the value 3 and I get precisely the same result. So there's one angle, I suppose, to script optimization that can be automated, but of course there's more.
With functional results of that form, you can also validate using hashes and other hash functions. You don't need to always use the most complex hash function, hence why you've got sort of 160-bit hashes as well as 256-bit, because if you can save a little bit of time, values, etc., then that's a good thing. And with sort of nested if functions and all of this, of course, rather than having a particular bit of script run, you could actually have an option of excluding data in your script as well, but validate the result so that you've potentially run certain inputs and outputs and whatever else, and then you validate those.
Well, I'd like to dig into some of the design choices that were actually made around the scripting language, because it is very much based on Forth. I recommend anyone go to forth.com and read some of the tutorials there. It all looks incredibly familiar. It has 1 or 2 features that Forth doesn't have. For example, the checksig opcode is not native Forth. And it's fairly obvious the reason for those. But it also has a few features omitted from regular Forth. So I want to get into those in a moment. But first, I just want to go back to script as a predicate. You raised it before, and you defined predicate as something that can have true, false, or not valid.
Yeah, syntactically incorrect. Yeah. Syntax error. For those who remember old DOS Windows.
So why does it matter that the output of script is a predicate?
So basically, we want something that is easily checked and validated. So the nodes out there have to be able to quickly validate this as being a true or false result, so that they can quickly either decide to incorporate it or reject it. Now, this is one of the problems you have in sort of looped virtual machines that can run for a long time and don't come to a necessary end, like some of the Ethereum type people are trying to run. You don't actually know whether there's something in the future that could cause a problem, and you want to have a final transaction when you put it into a block.
So one of the important features of Bitcoin script is that it appears to quite deliberately limit ways of importing, I suppose, external state. You can put data into script-sig, but once that's done, there's no way after the fact to bring external state into script. And this principle has actually been kind of historically violated, and there's a well-documented discussion, robust discussion about check lock time verify, which had a couple of names before it became CLTV, which basically has the effect of importing the current time or block height into scripts. What's the issue with that?
There are actually a number of ways you can actually put external state into the system using that. We actually have a patent in nChain based on it, which I decided to cause a few problems by doing. Now, using a whole lot of sort of logical constructs with end this time but not that time and whatever else, should write it up on a little blog now that it's in the patent thing properly. You can actually have scenarios that may or may not be correct, and aren't necessarily final the way that they're meant to. And that's a problem. So if you've got something that's in a block, but the effects mean that the transaction can change, so that 2 transactions can both be valid or invalid at different times, then you start to have a problem with the integrity of the chain. There are conflicts that can happen between miners and ways of actually splitting chains and causing problems that would actually be completely legal, that then the creator of the particular transaction has caused. So you're introducing potential vulnerabilities.
Yeah. So I can see how check lock time verify could cause a transaction that is invalid now to become valid at a later time. I don't know if it can go in the other direction.
It can actually. The workaround that Bitcoin Core has is they don't allow script.
Yeah.
So, I mean, some of these things, of course, require script. And if you just stop everything and say it's not standard, you can't use it, that sort of makes it more difficult. Although non-standard doesn't stop a miner from taking a transaction.
So in-lock time is another mechanism to affect the validity of a transaction based on time, but in-lock time is dealt with and enforced outside of the script itself.
Which makes it far more powerful. So this whole mythology of has to be on-chain or it's not valid, well, that's very paternalistic when you think about it. So there are many ways of having a transaction that won't be lost. You can even write the transaction into the blockchain so that if you lose it, you've got a copy. I mean, you could honestly put it into op push data, op drop, and just have a transaction written into a small dust transaction, just so that you know that your transaction won't be lost. You could always go back to the blockchain and find it.
Yep.
So, and if you're going to lose a transaction, I mean, the whole CLTV bit versus n-lock time is, what if people lose their transaction? What if people lose their keys? I mean, it's the same thing. Where do you stop? It's a slippery slope type argument. I'm going to protect people from doing stupid stuff. But what if they do this other stupid stuff? Well, then we'll invent something new to protect them from that and whatever. How about you actually require people, you code it so that your keys and your transactions are stored in the same thing. If you lose your keys, you lose your transactions, vice versa. It doesn't matter so much then. And then get people to back them up.
So it's interesting you mentioned the idea of transactions don't necessarily need to be on-chain for various reasons.
No, and it's more powerful. I mean, if you think about n-lock time, you could have billions of options. I could write a billion possible transactions, all of which happen in the future with an n-lock time or now, and let people choose them after the event.
That's almost topical because just this week, Wright released a product called PowerPing, which is I guess a social media network, and it stores messages in Bitcoin transactions, but they're not on-chain transactions. They are signed, but they're not on-chain. How I don't know, or I don't think that he's using n-lock time, but what is, I guess, the value of a data packet wrapped in a transaction format if not put on chain?
Not everything needs to be put on chain. So, and remember, you have indexing and hashing functions. So you can put things on chain without them having all the data on chain. So you can index things and have them in separate databases. Now that's going to be essential in the future, especially if you look at last week, the European courts have said to the American sort of technology companies that they can't share data. So if you have a hash and an index function on chain, and then you separate the database, that's going to be allowable, even when you're talking about identity and things like this.
So we're talking about external state on chain, and we've talked about CLTV and some of the potential problems that it can cause. Now, there's one particular opcode in Bitcoin script that necessarily imports external state, and there's a boundary around what it imports. It's opchecksig, but in order to calculate the SIG hash, data from the transaction that the script is contained in, but outside of the script, is basically imported, hashed, etc. And this technique that has been notionally called op-push-tx actually was invented by N-Chain a few years ago. Ying Chan, who's on his way back to N-Chain, is one of the primary inventors. And it makes use of checksig basically as a comparison function so that you can push the content of a transaction into a script and then use the comparison function to confirm this is actually the transaction. So how does that play as in terms of, does it violate this principle of importing external state?
No, there are sort of limits on what you can do with that. So the guys there have taken, I originally started using the RNS components of the signature and showed how you could actually do some calculations with R, the R of the RS part of an ECDSA signature, and import that in to be calculated in the scripts to get different results. But the thing here is, once it's written into a block, it doesn't change. You can have possible different alternative answers, but the first one wins.
Yeah.
So that's a difference with something like CLTV. CLTV, it's written into the block, but the results are still ambiguous. Whereas here, there are different things that can occur and multiple transactions that will be valid. But once they're actually solidified in a block, they're unchangeable.
Okay, so you're making the argument then that a CLTV transaction could potentially be valid written into a block, but then become invalid later after it's written into a block?
Potentially, especially when you've got chain transactions and things like this, you'll find that there's potential anomalies that will happen with what miners do. As I said, Bitcoin Core have got around this. They don't allow script. So, CLTV, you can't attack it at the moment unless you're a miner because, well, you have to allow script to do the attack. So the fix is we disable script. So you nobble the protocol and you cut out all of the real use cases outside of cache, and then you make it unusable as cache, and you go, we fixed it.
Okay. Well, I want to move onto the.
It's sort of like if you imagine C, and you make it completely safe by taking away all mathematical functions and all string functions and everything that's useful. And
well, we removed opmul and division, multiplication, modulo, etc. So I had to go through quite a lot of work to bring them back. So I want to move on to the subject of loops, but no discussion of what push-tx would be complete without a shout out to the script team and Stars in particular, who actually took this technique and in what I think is a record time actually implement. So on to loops. There are no loops in Bitcoin script. You can simulate them by unrolling loops. The reasons seem relatively obvious when you've got a system where computation has a cost. It's not hard to make a loop that goes on forever. Why not allow them in the script language itself rather than miners simply implementing some kind of timeout on the runtime of a script?
yeah. So as machines get faster, as people involve more machines or invest more, you get different results. How do you have a predicate system that is reliant on how much a miner decides to pay for their computer? And then if miner A has a big fast data center and miner B has a lot of ASICs but slow computers, you get different results. I mean, do you have to have every miner run exactly the same equipment forever?
Well, this is an interesting issue that popped up for us during the design of the Genesis upgrade, because when you allow unbounded scripts, it's obviously not that hard to create scripts that have incredibly long runtime. And we put in an optional timeout that that miners can use, but of course it's impossible for that to be enforced at a consensus level because your computer might run faster than my computer. How do you actually measure that in a way that can be kind of widely agreed? But runaway loops, accidental infinite recursion, that was also something that you were looking to prevent.
People may not know, but I did a lot of training with the SANS Institute in the US, and that included things like doing the secure coding courses and things like this, and helped with some of the cert course development for C, Java, and .NET coding back in the day. It's all old now, we're talking over a decade ago. But these are, it's not such an issue now. Microsoft actually takes security a little bit more seriously. I won't say totally, but a little bit more seriously, to the annoying level where they reboot your machine all the time. But back 10, 15 years ago, even 20 years ago especially, a lot of sort of software development houses, including Microsoft, really didn't seem to care about security at all. And a lot of these things were rampant at the time. So we were seeing hacks and compromises all the time. And I didn't think a financial system would work if people could do that with money. Imagine if someone could attack home loans or something from a large bank that were scripted, or bonds or something like this, into Bitcoin and cause trillions of dollars worth of damage. You can't build that in. It's not, Windows 95 was bad enough. We didn't need to build it into the financial system.
So loops aren't necessarily about, I guess the risk of loops isn't necessarily about what you know at compile time, because at compile time you don't necessarily know what
Remember,
the inputs
there's
are.
branched conditions within Bitcoin too.
Yeah.
So that then allows us to have race conditions, and we can have, if you have loops and if statements and branching, then you can actually have loops that will be faster on one set of machines than another, and different nodes will calculate different results based on which things finish first. And if you're going to be doing that, then you cause all sorts of problems. Once again, we can't say what machines nodes are going to run. We can't go out there and say, you must run this machine from HP and it must be in this configuration and whatever else. That sort of precludes the whole nature of what Bitcoin's about.
So the foundation of a financial system needs to be risk-averse. Is probably a short way of putting it. So fourth is a very technical subject, but it can lead us towards some less technical ones. We've spoken about how stack management and things like that have a tendency to impose discipline on a coder. I'm pretty sure, I cut my teeth on strict type languages. I have played around with PHP. I'm still in therapy. I'm pretty sure that you have a kind of a similar background in terms of the types of languages that you've worked with. Why is discipline in coding important?
Okay, so we have a history in computer code of problems, and that is even in critical systems. And it's about time we stop being cowboys and actually make things that are reliable code. So this goes right back to one of the earliest ones were X-ray machines that killed a whole lot of people because they overdosed. That's like 30-something years old now. But just a typo and in the code led to 10 times the amount of X-rays being put into people who were then actually died of cancer. So everyone sits there going, it's just code. But just code. Well, what does code do? It runs cars. No new car now. I mean, we're not even talking about automated. Your braking system is all code. Your steering is code. Your engine management system is code. If we don't do this right, then we have problems. So we're getting rid of the jumbos, but all the new planes are all fly-by-wire. Your 787, your 777 are all basically big computers with engines. What we're going to allow them to be attacked and things. And again, this is finance. It's the underlying basically feature of how society works, how it's measured, how it's controlled, how people own things. And if we take this even further in the future, where we start tokenizing goods, we put property records on chain, all this sort of stuff, then not doing good code is a disaster waiting to happen of epic proportions. And I don't want to be the cause of that personally.
So I guess speaking of coding discipline, we've mentioned typing quite a lot, but the interpreter itself actually has no notion of type. It has one type, which is an array of bytes, and those bytes can be interpreted as numbers. They can be interpreted as booleans, even strings. And it makes me think, I suppose, of JavaScript and TypeScript as an analogy, because you can actually impose a typing system over the top of script at compile time, but the interpreter itself has no kind of notion of type. Was that always your intention, that script was going to have like compilers overlaid on top of it?
Yeah, definitely. It's like assembly language. Then we form higher level languages and better tools. So Forth is a very low level language in a way. And if we really want to make it robust and easy and available to a lot of developers, we need to make simpler ways of doing things. So as much as it sort of galled me when I had to do it, 10 years ago now, the university, when I was still teaching there, made me do Ruby on Rails because it was getting popular. They made me do pretty colors and things like this, which is definitely not my forte. Anyone who's looked at the original Bitcoin sort of logo, which wasn't the B with the two lines through it, was BC.
Yeah, so it might interest some of you to know that the version of the Bitcoin script interpreter in Bitcoin J, which we have internally at nChain, is heavily modified and is slated for future release at some point, actually does have the capability to enforce strict typing on it, which is not something that you would actually use on chain, but in live transactions. But when you're building transactions and testing transactions, there's nothing to stop you from adding these type checks, which just add an extra level of fail fast, because it's probably much better for your transaction to fail at test time than it is once it's out there.
Well, this is the thing. We're never going to have an army of people who are super experts and know everything to do with code and really take it to a level of artistry. The reality is it's always going to be a Pareto distribution. You have a few people who do the really, really difficult things and a lot of people who do a lot of functional work. That's how everything works in society. It doesn't matter if you like that or not, that's reality. And if you start looking at what we now have is a few people who can develop all the tools that others can use.
So we're waiting for the emerging generation of script artists.
We are.
Well, some of them might be watching today, or some of the future ones even. So discipline. It's an interesting word, and in fact, it's something that I observe in you in your kind of daily life. Not that I spend every day with you. I need someone to talk to if I did, but one thing that strikes me is, I based on random messages, etc. I have some sense of when you go to bed and when you get up, and we have a sense of what your kind of daily life looks like, and it is incredibly disciplined, and a huge amount of that time is devoted to education. There are other elements, though. I mean, I've been out with you on a heavy night, and I know there was no way in hell I was getting out of bed early in the morning, but you're still in the gym at 6 a.m. You're still doing your Chinese language lessons, etc., no matter how shady you might be feeling. But there's an incredible drive in you when it comes to education. And I think if there was one subject that could cause people to mistake you for an altruist, it would be on the subject of education, because you are really passionate about it, not just for your own education, but for people at large. What is it about education? What is it that makes it so important for you and for it to spread?
For society, democratic society especially, to actually work, we need people to be involved and informed. And this is one of the things we're not teaching properly anymore. I have made this argument a number of times, but there are two aspects of going to uni and other things. There's education and there's training. And these used to be separate. They're now getting mixed up. And training is when you do your law degree. There's one of the few areas where you still do 2 degrees is law. So you do like your BA or a BSc, and then you do your Bachelor of Law. And they generally expect you to have education first. Not always the case. You can do some rather iffy degrees these days and still call it education. But it's about how to think and being part of society and the world. So I make this point, Bohr's, behind quantum theory, etc., was also a philosopher. People don't actually understand that one, but he wrote and did philosophy of science, philosophy of logic. One of the philosophy of Western world is sort of written by a mathematician who's also a philosopher. We have many people in history who are scientists and mathematicians and philosophers. And if we want to get past this whole postmodern deconstructionist, anti-life, nihilistic view of the world, then we have to have people who are involved and trained and educated. And you can say that it's not really anything other than selfish in a way. I want a world that is better. I want to live in a world that is better. And if I want to be in a world that is better, then that means people who are engaged in society, who are active, who know what they're voting for, who understand the issues and can debate them. So one of the things we should be doing is educating people not with agendas. People should be taught a variety of topics, even when they're coders and things like that. They should be taught some philosophy, some art, some science. But they should learn how to debate, how to actually express an opinion, why to have an opinion, and to learn, not just everyone says. And you should be able to openly debate this the way that society has built over the many, many decades, many centuries since the start of the Enlightenment. Why is the individual important? We need to be able to express that. And it's one thing to write code or math, but if you can't actually express this to people and you can't have that debate or argument, then you're not really being effective.
Everything you describe here seems to go to the concept of making the world, generally a better place to live in, if I can boil it down to really simplistic terms. Why not say screw the world? I mean, you got enough money. You could go off into your own bubble. You could probably, have whatever kind of a life that you want and whatever you need brought into your bubble. Why bother with trying to improve the world that you live in?
What is the purpose? I mean, at the end of the day, the ultimate evil, in my opinion, is nihilism, emptiness, and that's what you're describing. So, if we want to be a part of things, we need to understand that we have this world of different people. I mean, I have Asperger's, and it's difficult for me over the years to really get to understand other people's minds. In part, I do that by studying. So, and I try and read and learn and see what's happened, which has taken me through a lot of history as well, but and some psychology and some other topics. But what is the purpose of life if that's all you want? Think about it. Why do anything in the first place if that's all you want? Why not just be a warlord and cause problems? Or, I mean, why not just commit sort of seppuku and disappear now if it's empty? I like to believe that there's some reason more than emptiness that the universe exists, that it's not just a infinite series of bubbles and we're going to do this talk again and again forever. And there is much more to everything out there. I mean, people don't look around. There's some remarkable architecture. There's art. There's beauty in nature. There's
So part of what you want then is interacting with the world.
Correct. Everyone wants to be interacting with the world. How they do it is a different question. But we should be looking at a world where we should imagine ourselves in different positions and what happens in different places and all the rest. And if we want to be honest with ourselves, which I think truth is incredibly important, then we can't just sit there in a sort of isolated little thought bubble and decide this is all going to work really well for me. I mean, we don't act in isolation. No one does. We can't. Not as people, not as countries. We're connected. So
would you say that there's an implied moral obligation upon people to try to make the world or the part that they can influence a better place?
I think so. I mean, I think all of us want something more from the world, and the only way that we can do that is to give back. It's going back to Adam Smith, and not just his work on Wealth of Nations, but moral sentiments. If we want to actually be part of a world that's going to be effective, then we have to actually engage with that world, change it, alter it, and sort of understand why it is the way it is. And this is rather problematic at the moment. So we have a world in this woke re-envisioning of society where we're trying to rewrite history, and that's wrong. I mean, when you think about it, if you don't understand history, then it's not even that we're doomed to repeat it, as Fukuyama and others said. It's more that we're going to make it worse. We are in the best part of human history ever. There's never been a golden age like this. There's never been so much. And contrary to what people think, we're not running out of resources. There's only one resource that gets us everything we ever need, and that's energy. And we have plenty of sources if we think about it. The entire economy comes down to energy. We want more iron, energy. Want more gold, energy. Want more food, energy. I mean, right now we could build underground bunkers and populate them with all the resources, and feed 1 billion times the population of Earth without anyone noticing an ecological impact at all, with one thing: energy. So, and how do we do that? Well, that's knowledge and innovation. So if we want that sort of growth, which will solve poverty, which will solve everything, which will make people's lives better, then we need people who are going to think through problems, not sit there complaining about problems, but solving them. And that means education.
So I can try and frame what I think that you just said. You are driven to work to improve the world because it improves your experience of interacting with that world. It's almost like you're incentivized to do it. You're not doing it through any notion of altruism. You're doing it because it improves your life. And so you're expending
my family. I mean, the altruistic bit that everyone has is
the
people
family,
they care about. Yeah.
And so you're expending your energy and your work to write your little part of the chronicle of human history. It almost sounds like Bitcoin, doesn't it?
Yes. So I guess the thing to think about is we can all do something. It doesn't need to be great. It doesn't need to be magnificent. It doesn't need to be huge. But a little change. Everyone can do a little change. And just one little thing that we can do that doesn't seem much can go a long way. I knew a guy who was a postmaster in Australia for years when I was with the church, and he had a wacky hobby that I think his wife thought he was insane, which was growing orchids. And for like 40 years, he put lots of money into this, and everyone just thought he was a little bit crazy. And these days, he's actually, a lot of them are all around the world now with the new techniques in biology and being able to propagate them much easier. He's got all these different varieties that he's grown through the decades that are now sold in supermarkets and things all over the world. And people can sit there and go, but that's crass sort of consumerism. But is it really? It's making people's lives better. I mean, think about it. Having more food, that's crass consumerism. Not starving to death. Having the average age of your children being more than 5 years old before they die, that's consumerism. So,
I often think when people complain about all the various things that are kind of wrong with the world, that it's a matter of perspective and it's a matter of timescale. I mean, for all the things that one might point out that are wrong today, a lot of people could compare their life now to what their life would have been like 100 years ago, 200 years ago, and it's vastly improved. But time, I guess, perspective on time has a habit of colouring people's perspective on events. So,
well, I think it's more than that. I think people don't even realise. One of MA in history that I've been doing, it's covering sort of a lot of micro histories, not from the large scale history that most people see, wars and whatever else, but actually looking at rural sort of England, places like Surrey where I live and Coventry and other areas. And 120 years ago, it's remarkable how different things were. A lot of sort of these areas saw their first steam engine only around 120 years ago. They were still effectively in poverty, earning minimal wages, with most people being servants or labourers and living in crude huts with no flooring and things like this. And we're only talking about 120 years ago in England, and this was massively common. And these people had better lives than most of the ones in London that smelt like a sewer. I mean, I can't imagine what it would have been like around, say, 1860 in London, because supposedly the that's when it smelt better. Before that, when they had the sewers put in, the descriptions are something I don't think I mean, you go to the dump and that would be a nice summer day and they'd be all walking around going, this is a lovely day. It smells nice today.
Go for a picnic at the dump.
Exactly.
Yeah. So there's so many more things I'd love to touch on, and some of them are technical, but I think that we should sort of head toward an ending now, because that partly gives me an excuse to do this again. I have enjoyed this, but let's just touch on one more subject, coding. Now, you and I kind of have a bit of similar history. I think maybe we've walked a similar path with the coding, and a few kind of odd things in common. When I was 6 years old, I lived only a few kilometres away from you. But I should clarify that, and put any rumours to bed, I only met Craig for the first time in 2017. Although there were probably a few times when I could have accidentally, or we might have, and not realised it, particularly in online circles. But, we both taught ourselves to code, I think, as kids, and it became part of a lifelong obsession with developing these skills that enable building. I've got a fascination with a few sort of other things outside of that. I really like plumbing for some reason, which is probably why I'm a natural fit for Chain. And I like metalworking and woodworking, which because they have that sort of that commonality with coding, they're tools that enable you to build stuff, and to be able to create is fantastic. It's empowering, I suppose. So when did you first start playing around with code or with building skills like this?
I actually started way back. I mean, I got my first email, which wasn't really my email. It was a University of Melbourne computer, a VAX, a digital equipment machine, because my grandfather was involved with something, Cree, Robert Ells, who was, if anyone remembers the old domain system in Australia. It wasn't only Americans. A lot of stuff happened in Australia. My grandparents used to look after me because my mother was working, and I got sort of shoved on a computer, so I'd shut up. One of my things my grandfather did when he got sick of me, he just put me on the terminal. It wasn't really a computer, it was old DEC terminal, green screen, with a 375 modem that you'd watch the characters go across the screen.
You could read faster than that.
Yes, you could type faster and then watch it catch up. So that was back then, and I really got into coding for naughty reasons, which was, well, how do I get into other things I'm not supposed to get into, because no one's letting me out of this little tiny useless room that does nothing. All I can do is code games that I get sick of, because used to get basically games you'd get in magazines, and you'd type out and play and vary. And
I remember those. I typed a few of them, and they were quite painful when there was a typo right back at the beginning.
Then you'd modify them so your sisters died early and you got more playtime, and things like that. But yeah, so getting sick of being stuck in those areas, which and extending privileges and seeing what was on the network, which I know is naughty, but when you're sort of preteen and teen, it's...
Well, I've heard that it was a lot easier back in those days. I mean, etc password was a plain text file. You could finger all the usernames. There was a finger bug, still FTP bugs. Half the time, the root password was either password or root. All the VAX machines had a backdoor in them, which digital equipment put in to make it easier to actually manage, so that they didn't need to try and backdoor their way in the machines. They put a backdoor in.
So, but yeah, no one really thought about that sort of thing as a problem at that stage until the school did, and I got in trouble at school once because of I didn't actually change my grades. I changed everyone else's.
And let's leave that conversation there. I was worried that this was going to turn into a pissing contest about who's used the most primitive CPU at some point, but I'm not going to go there because I suspect you win, but I will point out you have a few years on me, so you're at an unfair advantage.
Mm-hmm. Picking up my age again. Actually, ageism.
So we're gonna draw this to a close in a moment, but I've just got one last question for you. Actually, two last questions. The first one: it's been a long time since Bitcoin's inception, and I think the last couple of years have been probably the steepest learning curve for a bunch of people learning how Bitcoin actually is supposed to work, as opposed to ideas that took hold and, well, are still trying to shake off 10 years later. But out of those people that have actually been like studying the white paper properly and working with Bitcoin
and other comments I made and other things that were there,
and there's a large kind of body of work. What would you say is the key people that people, even people who are focused on the Bitcoin SV vision, the key thing that people are still missing?
I mean, there's two parts to it. I mean, people who are working with us is different to everyone else. I mean, if you're talking about everyone else, getting people to understand that the sole consensus mechanism in Bitcoin is creating blocks. Therefore, you're...
No, I want to talk about the BSV community. So I guess this is an opportunity for you to sort of mark out a particular topic that you think people should focus on. Like, is there anything particular?
I think getting people to understand that you can actually create a combination of on and off chain and do far more. So go back and look at all the old stuff. Look at Mojo Nation, look at PPay, look at these things that existed 20 years ago. So look at some of these old things, but don't look at them from the anarchist, we're going to have all the information-free BS, but start thinking about how we could actually make those into a service that helps people. How do we make it not a socialist, we're going to get rid of economics, and how do we actually make it into a system that gets everything out to as many people as possible for as little money as possible and scales without having ownership by advertising and data sale. So, I mean, that would involve getting to think a combination of on and off chain, using hashes to link external data, building parallel systems, building like overlay peer networks that then can utilize the foundation of Bitcoin to build far more. So, and starting people to take it into that next commercial level. So, getting past the internet.com stage that we're still stuck in really, and getting people to start that first sort of venture into Web 2.0 and Bitcoin. Web 2.0 didn't invent anything new at TCP/IP level. It built on top of that. It built external things. It linked databases. It linked other systems. And when people start realizing that, and they can do that on Bitcoin, that's when it's really going to change.
I look forward to seeing that. So I've got one last thing that I want to ask you about, Craig. Bitcoin's 11-year history has been a checkered one. And the list of things that have happened around Bitcoin that have probably pissed you off, and rightly so, it's endless. It's a massive list, and we know that Bitcoin has cost you dearly. But we're talking about Bitcoin's role in making the world a better place, I've certainly had a sense of the experience of Bitcoin over the last couple of years has been becoming far better. So rather than focus on all the crappy things that have happened over that time, I just wanted to ask you, what's one of the things that has made you happiest about what is happening around Bitcoin?
Getting things back on track. I mean, that has to be it. I mean, getting people like Scrypt and whatever else to won't be lost, using things to make it simple for people to create on top of Bitcoin. Having people start to use Bitcoin for the real way, little things like even hand cash and other PayMail and all these other little innovations that are actually quite big that people don't notice yet. They're only small in sort of expanse, but they're quite game-changing long term. And getting people to understand that all of that's important, not because we want to be able to have a drug money or heroin money. It's done all the time. I mean, Bitcoin's not going to get you something that the government can't seize. As soon as the government wakes up and stops listening to idiots and realizes that there's only a few nodes that you actually have to do anything against, and they're invested enough that you can use law, that exchanges are easy to control, then as soon as that occurs, then all of this changes. And they're starting to wake up finally. It's taken a while. So what we need to do is get everything in place so that we have something more than illicit uses of money. We have real uses of money, real financial sort of applications, real uses of secure code.
So if I can paraphrase, the thing that makes you happiest about Bitcoin right now is that people are starting to get it.
Yeah.
Craig, it's been a pleasure, and I hope we get to do this again sometime. So thank you very much for your insights. And I think on the subject of the theme of this discussion, Bitcoin Script, we're certainly starting to see things come to life and happen around that.